In this video, we're going to be looking at the fundamental relationship between the concentrations of hydronium ions, hydroxide ions, pH, and pOH. And so this is similar to the table that we made in class, and I'll give you all of these equations, but it's really good to be able to know how to use these. And so I think it's probably good practice to go ahead and make this table for yourself, because putting this table together is going to be a good exercise. All right, so in this problem, we're given the pOH, and we want to calculate the H3O+, the H+, and the pH of this solution. All right, so in our table, we were given this information, and so we want to find the pH, the H3O+. Remember, the H3O+ is the same as the H+ concentration. So even though I asked those separately, I did that specifically so that we could point out the fact that the H+ and the H3O+ are going to be the same. All right, so there are a number of ways that we could do this. What I'm going to do is we're given the pOH, and I'm going to first calculate the pH. So I would use this relationship. So I have my equation here again. So the pH is going to be 14 minus the pOH, so 14 minus 9.3, and the pH is going to come out to be 4.70. All right, so now we're back to our chart. So we started with the pOH, we've now calculated the pH, so let's now calculate the H3O+ concentration, and so we're going to use this relationship that the H3O+ is 10 to the minus pH. So I've got my equation again. So now and when I plug that in my calculator, I get this result. And remember, the H+ is the same thing as the H3O+. This is probably the more accurate representation of what's going on in solution, but we often use these two interchangeably. Okay, so now we've added the H3O+ to our table, and so the last thing we need to calculate is the hydroxide ion concentration, and there are two ways to do that. One way would be to do it just like we found the H3O+ concentration. That would be do 10 to the minus pOH. But since we've already basically done a calculation like that, let's use this way. So the fact that we have the H3O+ concentration, I can use this equation to find the hydroxide. So let's do it that way. So now the hydroxide is going to be and when I plug that into my calculator, I get that the hydroxide is going to be 5.0 times 10 to the minus 10 molar. All right, so now we have all the information that we've asked for. We don't really need to do this, but since we haven't done a calculation of going from concentration to the pH or pOH, let's do this calculation to show that when we do, we get back the original pOH that we started with. So if I calculate the pOH from the hydroxide ion concentration that I calculated, we get that same pOH back again, as that gives us confidence that we've done our calculations correctly.